Okay, so in this video I will be checking out the Non-K Alder CPU overclocking on these Z690 motherboards. So the Non-K Alder CPU overclocking has been a very hot topic recently because it offers a new range of very valuable CPUs on the market to purchase. So you can purchase a very affordable CPU which has in effect AVX 512 support, and you can overclock it to really increase its performance by quite a bit. The only negative part about the whole thing at the moment is that we don't have very affordable motherboards that do support this function. So as you can imagine, as many of the non-K CPUs, they are very affordable, like the G7400 is the dual core option, it costs maybe like 70 euros. The 12100F is a quad core CPU and it costs around like 110 euros, I think. This one that I'm running at the moment is the 12300, which is the most expensive quad core CPU. I think it's somewhere around like 150, 160 euros if I'm not completely mistaken. And then we have like the cheaper 6 core options like the 12400 and so on. They are very affordable, but as you can imagine, you definitely don't want to buy a 500 or 600 or 700 euro motherboard for a 100 euro CPU. So that doesn't make any sense, right? So the most ideal case would be if we had very cheap motherboards that supported this function, like maybe like 100 euro motherboard for a 100 euro CPU, or less than 100 euro motherboard for 100 euro CPU, something like this. The feature that you need on the motherboard to be able to overclock these non-K CPUs is external clock generator on the motherboard, and that's usually present only on the more higher end motherboards. So on any LGA 1700 motherboard you can overclock these non-K CPUs up to like 103 megahertz maximum, usually. That's the wall that you will hit on all of the motherboards without external clock generator. So for example, if we use the 12300 now as an example, if we go to CPU multiplier control and if we set manual ratio limit, the maximum multiplier this CPU has is 44 across all of the 4 cores. Cache you can move freely, but the maximum value is the same value as on the actual cores, so 44 in this case. Now you cannot move this any higher. That's what the K stands for. So K stands for an unlocked CPU, so you can move the multiplier freely. So that is locked in our case. We cannot raise this any higher than we want. So the only way to really overclock the CPU and the whole system is by raising the base clock. And as I said, 103 at maximum on any 1700 LG 1700 motherboard, and you can move this up freely on motherboards that have external clock generator. And well, obviously the highest end motherboard options do have this feature, like the Z690 KINGPIN, the Z690 Tachyon from Gigabyte, the Z690 Apex from Asus, the Z690 Aqua OC from ASRock, and so on. So that's the thing at the moment. So I've been using this 12300 for a few days now. I've tested it out like thoroughly from like CPU overclocking perspective, and I've also tried the memory, like how the memory behaves when the base clock is being raised. So just to make the video like shorter, I will just note out my main findings and my own tips on how to max out this combination. Sadly, this particular 12300 doesn't have very strong IMC. I tested the IMC both at 100 MHz base clock and also at elevated base clock, so at risen base clock frequency. So it does somewhat okay, but it's not very good. So currently I'm running the Corsair Vengeance DDR5 sticks that were able to do 6933 and 6800 up to 7000 on air cooling, but they cannot go any higher than 6500 or 6600 with this particular CPU. So that's a very sad thing, but no can do. The CPU is on water cooling, so custom water cooling, and then just the Z690 dark KINGPIN and with a very simple VGA. But anyways, so I will load my profile where I maxed out, and I will just go through the settings with you guys. So what I found out on this CPU, that when you raise the base clock like high enough, so over 110 to 120 megahertz, for some reason the maximum multiplier has been 42. So I don't know what's the reason for that. So 42, and that usually works just fine. So we need to find the maximum frequency we want to run by using a multiplier of 42. Cache on this CPU is actually pretty good. It's better than what I had with the 12900K and better than what I had with the 12600K. So I was able to do up to like 4.6 to 4.75 on the cache on the CPU. So that's definitely a very good result. Now a base clock 123.8 for 5.2 gigahertz. I currently set this for memory testing. The issue that I had, I don't know if it's like more or less a feature on these non-K CPUs when you start to overclock them, or just like a BIOS issue for this motherboard, but the AVX negative offsets, they do not work. So I didn't have negative like downclock when I ran something like Prime 95 or a similar test that utilizes AVX instruction sets. So that's a huge problem at the moment. So we cannot get higher frequency for non-AVX situations and then lower frequency for AVX-based workloads. So that's definitely an issue. The only good thing about these CPUs is that these are lower core count CPUs, so these don't output the same amount of heat as the higher core count options like the 6-core CPUs or the 12900K, which is 8 or 8 plus 8 core CPU. So we don't need as heavy like downclocking on these CPUs compared to the K models, but obviously with this kind of CPUs you don't use so strong cooling solution, obviously, so that can be an issue, of course. But anyway, so I will use these multipliers for testing, and I will demonstrate this to you guys. So I will set 2 for AVX/AVX2 negative offset and downclock of 3 for AVX 512 based workloads. All of these non-K CPUs, they do support AVX 512 out of the box, because the older Lake CPUs, they do support AVX 512 instruction sets when you disable the add-on cores, aka the E cores. And these CPUs like the 12300, they don't have any add-on cores by default. So FLL override, the BIOS recommends you to set mode 2 for this kind of overclocking. So for base clocks ranging from 100 to 300 megahertz, so I will set mode 2, V-core up to 1.35. When I measured the load line calibration, minus 75% was the most accurate one for me on this generation, so I will use that one. V-core PWM frequency is a tricky setting on these dark KINGPIN and dark motherboards, so maximum value is 1000, but it's not always the most stable one. I've had the best result with setting ranging from 650 to 850 kilohertz, so I will set 800 over here. My report on the VDDQ voltage continues, so on all of these like later BIOSes, lower value has been significantly more stable for me than a higher value. First I tried with a VDDQ value of 1.35 even on the CPU, and I had issues maxing out the memory or getting it stable in HEIMM test even at like 6200 to 6300 when I used value of 1.35. And when I just set the VDDQ down to 1.26, boom, the very same memory settings were completely stable in HEIMM test, both at 6200 something and at 6400 something. So you need to get this value like very correctly set. Even small changes or increments can have a lot of impact on stability. Input you can leave it at auto, so 1.8 volts, or raise it a little bit. Now I set it at 1.9 volts, which is a very mild like increase from the stock value. Those are pretty much it, so you don't actually need to set that much at all. Memory, you need to take into account the impact from base clocks. So now with multiplier of 5067, we would get a target memory frequency of 6273 mega transfers per second. I will increase it by a bit to 6438. This worked just fine, even with 1.42 volts. And 31, 38, 38, 32. So we can set pretty mild like settings over here. 30, 360 TRFC, and 318 and 5. The PMIC is a very important setting. Generally, the best setting over here is either mode 4 or mode 5, and it's usually pretty necessary to set this manually. So if you face debug codes of 3F or D5 or 54, try to change the PMIC turbo mode. Usually mode 4 or mode 5 is the best option, as I said. That's pretty much it. And in the boot section, the later BIOSes, they post and boot pretty fast. The post process is very quick, so sometimes you may have issues trying to get back into the BIOS. So even if you ramp delete key on your keyboard at the start, you might fail entering the BIOS, and it just loads the operating system very quickly. So make sure you enable PS2 devices support if you are running a PS2 keyboard, which at least I recommend for testing purposes and overclocking. But that's pretty much it. I will save and exit these settings, and let's look at the performance in the operating system and temperatures and so on. Okay, so I just booted the operating system. It was pretty easy. So 5.2 GHz, as you can see, across all of the 4 cores, and it's made by setting base clock of 123.8 times 42. Cache with a 35 multiplier is 4333, and memory is at 6436, or roughly like so. So now let's open up core temp, and let's try to run Cinebench R20. I just want to show you the performance and how the CPU can actually overclock it, because this seems to be a very good CPU. So I have very high expectations for this CPU on LN2. So let's start Cinebench R20. So quite a bit of variation. So the first core around 75 on the bottom one, and the second and third are like mid 60s. So seems to run just fine. Same frequency across all of the 4 cores, and yeah, so let's wait for this to finish. Okay, so the score was 4137. I think the maximum or the record score on LN2 is like 4600 something, but it's well below 5000 points anyways, somewhere around 6 GHz. So that doesn't sound very high. So the highest like frequency that has ever been run on these quad-core Alder Lakes, which are non-K CPUs, obviously, is somewhere around like 5.9 or 6 GHz. So that doesn't sound very high, because this CPU can run up to 5.35 on water, which is very high. I think I was close on 5.375, but I will show you. So let's go to Elite X1. For some reason we don't have the memory option available with the non-K. But now let's go over here and let's set 125. I just want to show you, so 5250, and I will set 127. It might be too high. Okay, so it's a bit too high. Memory is close to 6600 now, which can cause some issues. Yeah, so now we have 5.3 GHz on the CPU. I just want to show you like quickly that this can run. 5.3 was still quite easy, and 5.35 was quite on the edge, and it needed vehicle between 1.35 and 1.38. So let's go back to R20. So 4137. Let's remember that. So I'll just let this run, and let's look at the end result once it finishes. Okay, and cache is at 4416. This can definitely go higher, at least by 1 notch. So 42 21, so roughly 100 points. Let's go back to Elite X1. We can try 5.35 for you guys, just for demonstration purposes. So let's set, let's try 36 first. I think this can go even higher by one notch, but it's close. 4668. We can try. I will set this to 1.38 and 127. Doesn't have to be exactly 5350. 4.7. 1 point. Not sure, this might fail. So 5350, 1.38 volts. But this might fail though, but it did pass quite a few times already. It's definitely not okay, but it's on the edge. So I have screenshot somewhere over here. So 4272, 5350, and cache is definitely good. So cache can actually run like somewhere around 4.7. So this is definitely much higher than with the 12900K or the 12600K. So the cache can definitely go up to like 6 gigahertz on cold. People haven't been able to get very like good cache clock speeds on LN2. So that's pretty much it. But now I just want to show you the issue for like daily performance that what I experienced or faced. So let's close that one and let's go to Elite X1, and I will downclock a little bit because I want to demonstrate this for you guys. So we'll go back to 35, 1.20, like let's put like 1.24 and V core down to like 1.28 because we don't want to crash. So roughly 5.2. Okay, and let's open up Pro 95. I just want to show this to you guys. So small FFT and AVX1. So you can see, oh, and actually it crashed because of this. So it didn't downclock at all, and we crashed because of that. So 5.2 gigahertz AVX not possible. So that's the issue at the moment. So we need the downclocking to remain stable in this kind of workloads. Okay, so let's quickly try again. And so almost 124. Let's go back to 41 and V core because of the temperatures down to 1.28. So 5075. And let's open up Pro 95. Small FFT, disable, and AVX1. So you can see temperatures even at 1.28 volts when already up to like 75-ish, but the frequency stayed the same. So you can imagine this will be very problematic if you buy these non-K Alder Lake CPUs and you don't have the AVX negative offset, because then you need to find a daily overclock that suits all cases. So even AVX 512 situations, and that is very problematic. So because of the temperatures, I mean. So if we don't have any access to negative offsets, we need to overclock the CPU based on AVX 512 limitations. So we need to remain stable in every possible situation. So even AVX 512, that will give us a lot of issues. So we can actually try it, just out of interest. So let's stop it. I just want to like see the temperatures. So let's play it very safe. Let's go 33 and let's go to 37. Let's go back to like 1.2 volts. Let's try this first. So now like 4.6 gigahertz, 1.2 volts, cache, a bit over 4 gigahertz. So let's try these temperatures. So first, small FFT, let's disable AVX completely. So no AVX, we have around 55, well under 60 degrees. Let's stop this test. Options, torture test, small FFT, AVX1. Around 60 degrees Celsius. I don't know if this current or package power consumption is correct, because these temperatures sound way too high for this kind of load. That could be like misread or misread from the CPU. So let's stop it again. Go to torture test, small FFT and AVX2, like 65. So we are now like 10 degrees higher than what we had without any AVX load. Let's stop the test, and finally torture test, small FFT and AVX 512. Okay, so this is very interesting. So AVX 512 has lower amount of load than AVX2. I don't know if this is functioning like correctly, but based on the Y Cruncher results, it seems to be functioning like somewhat correctly, because these Alder Lake CPUs, they do have AVX1, AVX2 and AVX 512F. I don't know what the F stands for at the end, but these do support AVX 512. So now you would have to find a clock speed that's like AVX2 stable based on these results. So if AVX2 has higher load, then we have to play by its rules. But we can actually, just out of interest, let's try it very quickly before I show you the memory. So let's go up again, 35, 30. Okay, so this is very interesting. So we can drop the frequency, but we cannot get it any higher inside the operating system. So that's very annoying. So we cannot overclock if we do any kind of downclocking. So I'll have to reboot this once. So I think I could have some chance getting this CPU like AVX2 stable somewhere around 5.1 gigahertz, between 5 gigahertz and 5.1. So that would be like maximum daily stable overclock, like all around, maybe. So let's go 1.3 volts and around 5.1 gigahertz. So it's currently at 5075 megahertz. Let's open up Benchmate, and I will show you Y Cruncher, because Y Cruncher does utilize AVX 512, and based on my earlier tests, the temperatures went too radical. So it could be that for some weird reason the AVX 512 doesn't have as high heat load as AVX2. So it's very interesting. So run. It doesn't seem to be that bad. It's actually lower than what I had in Cinebench R20. So, but this should be, well, at least the performance would indicate that this is utilizing AVX 512. The record score in quad-core category is 31 something seconds, and I think this should score somewhere around like 37 or 38 seconds maybe. 36.118. So not too bad, I think. Of course, the cooling solution is way too overkill for this kind of CPU. And after this, I just want to quickly show you what would the temperatures look like with AVX2. So I think I could try to aim for 5.2 gigahertz in Pro 95 with AVX2, but it's definitely hard because the temperatures will be 5 to 10 degrees higher than with AVX1 based on that earlier test. So new folder and Pro 95. Let's try this quickly first. So small FFT and only AVX1. Already around mid 70s. I think that will hit 80 over time. And let's try AVX2, and does it hang like straight from the get-go. Disable AVX52. 85, 88. I think this could be possible. It does need some time, but it's definitely in this range, so between 5000 and 5.1. But you can see, even with this kind of overkill water cooling, it's already creeping towards 90 degrees. So it's definitely warm. But this is like what you have to go with, at least if this is correct. So no AVX negative offset, and it's definitely not good. But even so, even if we had negative offset, most of the heat would come from the V-core anyways. The clock speed does affect the temperatures, but not as much compared to the actual voltage. So yeah, somewhere around this mark. That's what I would aim for. But at least 5 GHz would be doable with the CPU. So that's already pretty good for AVX2. And now the last thing is the memory. So as I already said, the maximum frequency I was able to do, like fully HEI memtest stable, was 6436 or somewhere around that mark, a bit under 6440. So 6600 was the maximum speed, like 6600 to 6700, which I was able to run in tests like Geekbench 3 and so on, but I just couldn't post and boot and run like 6800 to 6900 plus successfully with the CPU, neither at 100 MHz base clock nor at Risen base clock speeds like 120 plus and so on. So it's definitely the IMC, not so much about this unofficial like way of overclocking. So the maximum memory speed doesn't drop dramatically once we raise the base clock. But this was completely HEI memtest stable, so roughly the whole capacity was being used, and most of the subtimings were at auto though. But then, based on like this result, if I couldn't like go any higher on the frequency, I would just tighten the subtimings and get this configuration tighter and better performing. So that's what I just wanted to say. So that's pretty much it. So the non-K overclocking is definitely interesting on the Z690 platform. So this is more or less like an enthusiast or hobbyist option. So you aren't going to be purchasing these higher end motherboards for these non-K CPUs for like daily use. I think there are some, I think DeBauer showcased some cheaper alternative that did have the external clock gen. So you should look at those options more if you really want this low-end CPU for daily use. So the 12100F is better from value perspective than the 12300. It's somewhere around like 110 euros, so it's quite cheap. But a realistic motherboard for that kind of CPU would be somewhere around 100 euros. So that's really the issue at the moment. The 6-core non-K are more like realistic. They are, I think they are closer to 200 euros, but that kind of CPU is very realistic if you get like a motherboard that does support non-K overclocking for somewhere around like 150 to 200 euros. But then you aren't that far away from the 12600K and the 12600KF already. So that's what I just wanted to say. But this is pretty good. So pretty happy with this end result. So the cache is pretty wicked, and the core up to 5.35 to 1.375 on water cooling. So that's definitely a good result. Many people were running just 5.5 GHz or 5.6 GHz on LN2, and I'm actually quite close on 5.4 on water. So I think that's pretty interesting. So I definitely look forward to testing this CPU on LN2. Stay tuned for it. It will be coming on my channel somewhere in the very near future. So if you like to see this first non-K overclocking content from me on my channel, then please give me a thumbs up and subscribe to my channel. And thanks for watching one of my videos once again, and I will see you on the next one. So AVX 512 stable at 5.3 GHz and 4.67, 4668. It's pretty interesting.